In this video, we're going to learn about automated machine learning, or AutoML, one of the most important techniques today in business intelligence. First, I'll talk about the problem or challenge of optimization of parameters. One challenge that we face when modeling is what choices of parameters to make. For example, for a decision tree, what depth of the tree should we pick? What criterion should we pick? Gini index, gain ratio, or what? What tolerance? Should we prune or not? To how aggressive? It's very hard to know exactly what to pick, and there's various principles for each statistical procedure, and definitely more experience gives an idea of what might work better, but the truth is each data set is unique. And that means that the settings that work well for one data set might not work well for another. And a third data set might need even different settings or different models. And there's no one who can know beforehand just by looking at data sets what is the best thing to pick. So the best practice is just to try lots of different things, but to do it automatically. That is to run algorithms that try one thing over another systematically. So this is called the optimization of parameters, or hyperparameter optimization. And RapidMiner offers two main operators to do this. One is optimize parameters grid, which systematically goes through all the possible combinations within the ranges that you specify. So for instance, you might say try depths of trees from 5 to 50, one depth after another, run over and over again. Another approach is optimize parameters evolutionary, which uses some heuristics to not try every single one. They might start with a 50, and then they go to a 5, then go in between 25. They find that 25 and 50 are better, so let's go to 30. And in an intelligent way, it tries to find the best setting without going through every single thing. So these are ways that can be programmed in your design. Now, a very related topic, though it is partially distinct, is feature engineering. And feature engineering, well, engineering sounds like a big word, but it means taking the features, that's the predictors or the variables in the data set, and kind of transforming them in a way that you create new variables. So it means creating new variables from the existing ones you already have. Some examples are that if you have temperatures that range from 0 to 30 degrees Celsius, well, you can convert them to three categories. 0 to 10 is cold, 10 to 20 is warm, 20 to 30 is hot. So you have now three categories instead of just numbers. You might convert salaries to logarithmic values so that people with very, very high salaries don't weigh exceedingly more than others. You might convert minutes worked to hours worked so that there's not such fine distinctions. You might do customer analysis to create clusters of variables. So these are lots of different examples of how you can transform existing variables to new variables. It doesn't mean you remove the old variables, is you're adding these new variables. And the reason you do this is that very often the engineered feature might find better results than the original ones. And the reason for this is that we are trying to represent reality in our data set. Any data set takes an extract from reality and simplifies it. And we don't always know the best way to represent reality such that the model can pick up on it and make estimations or predictions. So by feature engineering, you give it more chances by representing reality in different ways, and different models might pick up on some ways of representing it and give you better results. Automated or automatic feature engineering is based on the fact that you can imagine it's hard to take every data set, every variable, and create new features for them. Um, so automatic feature engineering uses some algorithms to automatically transform systematically different variables and maybe decide which ones to keep or not, and then ask them in. So one disadvantage to this is that it is very processor intensive, not just for creating the variables, which might not be such a big deal, but now with so many more variables in your data sets, the analysis could take exponentially longer. Anyways, very often feature engineering is very much worth it because of the increased results that it might provide, or sometimes it doesn't. If you want to learn more about this, I highly recommend this free online book written by some of the leading data scientists, specifically dedicated to various approaches to feature engineering and selection, uh, including automated approaches. So, automated machine learning generally refers to having the computer automatically try many different models with many different settings to find what's the best. It can run hundreds or even thousands of different models that it generates, and because of that, it's quite processor intensive. That means it takes a long time to run on any computer that you run it on. There's some packages that have general good performance. Now, I'll say virtually every data science package today has automated machine learning in some way or the other. But two packages I can highlight. H2O AutoML is an open source platform that has libraries in many languages. It's actually written in Java, but it has extensions in R or Python. And other program languages as well. Here are some links to tutorials that explain how to use it. Another automated ML platform to mention is Google Cloud AutoML, which also has some very good algorithms as can be expected from Google. Now it's not free, but one major advantage why I'm highlighting it is because you're not just paying for the algorithms, but you're also paying for the cloud servers that will run those algorithms. So instead of running your automated ML on your own computer for 3 or 4 days and can hardly do anything else while you're doing that, you run it on Google's cloud servers, and of course you're paying them for to be able to do that. RapidMiner also has an auto model platform or module which implements automated machine learning, and it's probably not the best in performance in the world, but though it's pretty good. But one thing that I really like about it is that it's really very good for explainability features. That is, it has a lot of features built in that would help managers to interpret the results, and that means that they can more easily translate it into organizational decisions. Now, that brings us to a major consideration about what managers want to get out of data mining. And there's a paradox between accurate predictions and meaningful explanations. Because obviously, everyone wants accurate predictions. That's why you're doing machine learning. You want it to accurately predict what rows have what label values. And automated machine learning gives the best possible results because you're not just trying one thing that one expert is doing, but you're trying many, many things. And a machine learning expert might configure AutoML to give the best results. But the best possible results pretty much always come from automated machine learning. However, managers also care for meaningful explanations. That is, it's not just that they want the best accurate prediction, but they want an explanation. They want to understand why the model predicted that so that they can translate it into managerial decisions. And the best explanations come from simple models. That's the ones that are easiest to understand generally. Simple models like linear regression or shallow decision trees, meaning decision trees not with depth less than 5. And so these are those that can be interpreted and more easily translated into managerial decisions. There are some advanced approaches to meaningful explanations through an entire field called interpretable machine learning or explainable artificial intelligence, which tries to take in complex models neural networks and tries to reformat the results in a way that meaningful understanding can come out of them. Another approach to getting explanations out of modeling is simulations, where input values might be altered and then the model gives a result. So managers can change different input values and see how the result changes, and that gives them a very good idea of what is going on behind the model. Okay, so that gives a general idea of automated machine learning and that how it can play a role in business intelligence.